G'day, Josh here from Sensorite, down here at Boomer Bay today. We've got 3 sites down here due their 3 monthly calibrate. We'll also give them a bit of a clean while we're out on the water, and I thought we'd take you guys with us and show you the process and see what we get up to when we're out there. Okay, here we are at our first site down here in Boomer Bay, and we're just going to take a look firstly at the solar panel. I want to make sure it's nice and clean, so we'll give this one a bit of a wipe. Just give it the best chance. And that should be fine. Okay, next we're going to clean the sensor arm. Just bring that out of the water. And what we're looking for here is just to clean off any of the loose stuff on the arm, the sensor cap, and the float. This one's in pretty good nick, there's not a lot growing on it. What we want to do is look at inside of here that we've got a nice clean throat. That's the sensor inside of there. Just make sure that's clean, free of any debris. If it's clean, then there's not much more for us to do. We can put that back in the water. It should be right to go. When it comes to calibration, we start off with the same process as a clean. Pull it out, give it all a scrub. But for calibration, we really want to get in here and take a good look inside. Make sure nice and clean inside the sensor cap. If this is damaged or really dirty, then we can replace it with a new one. But that one looks pretty good. In here, we have the sensor and the protection for the sensor. So this is for the protection, and this itself is the sensor. On the sensor, the measurement is taken through the throat here for salinity, and then the top here is our temperature measurement. So we just want to make sure that the body, nice and clean, nothing growing on it again, and that inside the throat there is also nice and clean. So for this one, we'll just run the cloth through, it's looking pretty good. But we'll just give the inside a little scrub with the cloth. Another look, make sure it's looking nice and good. Same too with the protection here. We just want to make sure that inside of there, I'm not sure whether you can see it, but the little light there, it's currently shining at the minute. Don't want to look at that one too long, that's blasting UV light out. It's probably not as bad as the sun, but yeah, we don't want to try and get that in our eyes if we can avoid it. So we're just looking to make sure that that's working. Sometimes that light may be off, it just depends on the battery status of the box. But we want to make sure it's got a clear path into the throat of the sensor, and that we haven't got too much growing on the outside of this either. Again, this one's looking pretty good. A little scrub. If we need to, toothbrush down into there, give that a scrub. But that's looking pretty good. So we can reassemble those back together. We want to make sure that the measurement throat is in one of these little windows rather than in the long slit. And we should be able then to put the cap back on this one. When that's tightened up, you just want to make sure that the measurement throat has a clean shot through so that the water can go straight through and get the most accurate measurement. Alright, so we're going to have to calibrate the sensor. So currently that process involves removing the sensor from the node, plugging it in to our little box here, which connects it to our computer. And what we've got to do is get a measurement first in no salty condition. So we'll pull the sensor out of the water. And we'll leave him in free air to dry. While we're waiting, we'll get our calibrated instrument and we'll deploy that into the water and let that settle as well. Okay, looks like we've got our zero measurement, so we can hit next on that. Now we need to get our in-water measurement, so we will deploy the sensor back into the water and we'll wait for the measurement to settle, and we're looking to compare that with our handheld, which at the minute is 35.7 PSUs at 13.1 degrees. So once we've got the value from our calibrated instrument, we can input that here, wait for this measurement to settle, and it looks like we're about there. So we can send that calibration off to the sensor, validate, and that sensor is now calibrated. Now we can return the sensor to the node. And we're done calibrating for this site. This calibration process at the minute is a little bit painful. It does mean that we need to be on site, unplug the sensor from the box, plug it into a laptop, run some software. It's a bit of a process. We're working on an update for the boxes at the minute that will allow remote calibration of the sensors. What that'll allow is for someone to take a measurement, give the sensor a clean, take a measurement of the water using a calibrated instrument, and then pass us the date and time and measurement of the sensor at that point in time, and we'll be able to work out what the offset should be for the calibration, and remotely send that back into the sensor for it to store the new calibration. That's the first stage of upgrades we have planned. The second stage of development is a phone application that will allow someone to come on site, directly connect to the box live, and take live readings from the sensor. They can then, using a calibrated salinity probe, take a measurement of the water, and then the app will allow them to update the calibration in real time on site, nice and easy.